think I've got to switch and get rid of the window here. Back. Okay, so we're set. Okay, so let's start with going over in a hopefully rapid pace of what we went through yesterday, at least the new things we covered yesterday, and then we'll start with the new things, finishing up with a couple of features of Python plus we'll start playing with running scripts in as scripts, not as cells in a PyMol in Spider. So let's start with what we were doing yesterday. Okay, so we were dealing with getting to fragments of data, either to fragments of strings or fragments of lists. So let's try something like defining our string. My string, let's make ourselves a string ATGC ATT TGAC ATGC. Okay, so we've got a string to work with. We can also make the string into a list if we wish. So let's do it. My LST by coercing or casting it into a list. So now my str, we've got two variables, one with the string, one with the list composed of elements, each of which is one character. We can look at those by printing print my str and my LST. So let's run this chunk of code, and we've got the typo because it's supposed to be my. So let's rerun. Let's make this thing a little bit bigger for a moment. So now we've printed out string. It shows up as a string, and we also do have a list that was made out of individual characters, and here's the printout of the list. We know it's a list because it starts with a square bracket, ends with a square bracket, and in between there's collection of values separated by commas, and we know those values are strings because each value is surrounded by a quote mark. So here we've got two variables with two different types of data sitting there. To get to one of the elements of either a string or a list, we can use indexing operation, or by typing something like my str, and we can specify position. So we can, let's say, go after element that index 2. We do get G because, as you probably remember, we're starting counting from 0. So A is 0, T is 1, index for G is 2, so we're getting G. The same operation works with list. If we, instead of str, do LST here, we're gonna get G, but this time we're going after element of the list with the index 2, so we're going after this G here. If we want to get more than one element, we can go and use a slicing, or specify a slice. In case of string, we can, let's say, ask for characters starting from character with index 1 up to character with index not bigger than, let's say, 5. If we ask for that, we're getting 4 characters. This is because the first one is at index 1, so this is T. Then we're getting then we're getting 3 more characters. Last one is A because it's got an index of 4, and this is the last that's not bigger than 5. As you see, this operation returns a string. So those are four characters returned as a single string. If we do the same thing with the list my LST, we're getting now the same 4 characters, but now they are returned as a list with 4 elements. So slicing and works in a similar way for both strings and lists, except for strings with strings and lists. With strings we're getting string, with list we're getting list out of that. In both cases we can assign it to another variable, so we can have my s list or my sub st. So whatever is returned here is a list which can be printed sub st sub in the lowercase, and here we get the variable sub-lst returned after we assign the result of the slicing to the variable. So this is very similar for both strings and list. If we want to get every second, every third, every fifth, whatever character, we can provide a third number which tells us what's the increment between the characters we're getting. By default it's 1, so we're gonna get the same result as before. We're getting TGCA so we're getting 4 elements that are consecutive, TGCA. If we want to get every other character starting from first but not bigger than of index 5, we can say 2, and then we're gonna get only 2 characters or 2 elements of the list in this case, because we're starting from TCGA. So we're asking to scan from position 1 up to whatever is before 5, so up to 4, but we're getting only the first one, and then we go 2 up, so we're getting only T and C. And this is the same as with the strings. Is gonna be the same. We do my LST. We can do the same thing with the my string, and we can say that we're asking for 1 up to 5, stepping by 2, and now we're getting TC just as a string, not as a list with 2 elements. If the numbers used when specifying slice are negative, or if we're using only index to get 1 element, if those numbers are element at a given index, if the number is negative, then it means we're counting from the end. So let's arrange this thing here. So -1 is gonna be is going to be the last element of the string. I'm now printing. I'm printing the sublist. Where are we? Let's clean it up. Let's get rid of this thing. Let's just get rid of this thing and let's print my str -1. So here we're getting the last character of the string because we're getting using the minus here. If we want to get, if we use the negative number for a slice step, we're gonna invert the string and we're gonna read it backwards essentially. So ATGCA here starts the string, here ATGCA ends the string. So this is basic. Oh, and if the number is missing, it means depending if it's the first or second one. The first one missing means starts from the very beginning. If the second one is missing, it means go to the very end. So that's how slicing goes. It is the same for this. It works the same way for lists and strings. The difference between those two data types is that for a list we can assign to an element of a list. So we can, for example, say something like my LST 0, and we can assign a new value to it. Let's say lowercase a, and now if we my LST, if we look at it, not LST, my str. No, that's my LST, and let's print it. Let's do it this way. So here we're retrieving the first element of the list, and then we're assigning a new value to it. Once we print it, here's the new, the modified list, and you see the first element got changed. If we try to do it with the string, if we try to do my str 0 equals lowercase a, this is not gonna work because strings cannot be modified. You can only create a new string. You can create a new one by gluing things together, concatenating things, or combining multiple copies of a substring. But the result is gonna be always a new string that from then on cannot be modified. So that's why the operation here doesn't work. In a computer science jargon, it means that strings are immutable. There's a term for data types that can be only created once and then not modified can be modified any longer. Okay, so that's the indexing and modifying or not individual elements. There's, in case of, so we got here, in case of strings, we mentioned a few methods that we can apply to strings. Let's try some of them just as a reminder. We can try to find something in a string, my str find. Let's try to find t out there and see what happens. Well, find is going to return you the index of the first occurrence of whatever we're looking for. So if we're looking for t, the result is 1. This is because the first t in a sequence shows up as an element of the string or character with the index 1. So that's what find is gonna return. We can look for a single character. We can look for more than one. Let's say look for 3 T's. Now we're getting as a result 5. This is because the first character of the substring that we're looking for is at position 5, 0, 1, 2, 3, 4, 5. So that's what find does. Find tells us the position where a given substring is. If we're interested only in checking if a given substring is present or not, we can use in operation. We can just ask if TTT is in my str, and this operation is gonna return us either true or false, depending if the substring is present, but we don't get information about the number. So depending on the context, we can use either one method or the other. If the substring is not present here, you're getting false. If the substring cannot be found, you're getting -1. So in principle, you can use find to check if the substring is present by checking if the result is not negative, and then you're gonna be able to tell if substring is there or not. So this is finding things. We can okay. So then it's relatively common that whatever you read from a file, whatever the piece of data is containing extra stuff that you don't need. Sometimes it might happen that you're gonna read a file with a bunch of sequences there, and it might be that that those things are provided with a few characters either in front or trailing the piece of sequence you want to get, and they might be split, for example, into codons like this, and this might be the string you're gonna get hold of when reading a file, but all you want to do is just to get the characters there. To do this, we've got to use a couple of methods that will clean up our string. We can first get rid of the white spaces in front or trailing all the characters. To do this, we can use the strip operation or strip method. We can just say my str strip. Okay, and now it's sort of tricky to see if there's something in front or after the input string. So I'm gonna print it, but I'm gonna print it with padding colons. So I'm gonna start printing a colon. I'm gonna concatenate it with the result of whatever my strip operation is, and then I'm gonna add another colon trailing. This way I know that my string is composed of all, or the result is composed of all the characters between the colons. So I'm gonna be able to see it in an easy way in the console. I can clear the console for a moment. Okay, so let's run it. And as you can see, we've started with the string with leading and trailing spaces. We ended up with the string with white spaces removed. So if we skip the strip operation, we do see the spaces. This is this way of printing strings is useful when debugging, when you're trying to make sure that whatever you're feeding your function or your program is actually what we expect it to be. So, or if the operation work. So strip removes that. We still do have the white space in between the characters. It does the same trick as print does when it adds empty space between the arguments. There's a default parameter for the strip function, which normally is white space. If you want to strip, so you can, for example, if you well, it's white space. It's white space. So it's white. It's a space plus tabs plus new lines. So it's more more complicated than the white space. If you want to strip something else, let's say colons, I think you can just say strip colon. I think this thing works. Yes. Oh yeah, so I'm getting there. Just a moment. So that's stripping to to get rid of the white spaces or whatever in between. We've got to replace every occurrence of a space with nothing, and that's what this replace method is. So if we want to replace all the spaces with nothing, what we can do is, but let's first get our strip sec. Okay, gonna make our stripped sequence. Okay, and let's get rid of the columns. Okay, so here we're getting rid of the empty of the white space preceding and after the characters, and we're gonna just print strip sec. Okay, and now we want to get rid of this white spaces in between. So to do this thing, we've got to now start from strip sec, and we want to replace and we want to replace empty space with string with length 0. So this is what the replace method is going to look for. It's going to look for every character that's space, and it's going to put in place of it no character at all. Let's see what happens. Okay, now strip replace what? No, strip. Where my strip here. Okay, here. So here we're printing our string after stripping the leading and trailing white space, and then so here it is, and then replace takes this string and replaces all the spaces with nothing. So this also should convince you that that the methods working on strings do not modify the initial string. If we now, so let's get rep string rep set or clean sec. Okay, so here we've generated 2 extra sequence strings. Okay, we started with my str or my, let's call it my sec for a moment, and then my sec, and then strip sec. And this is supposed to be CL and sec. So here we've got, or make it ST straight, just my sec. Okay, and STR sec. Okay, so I think this is fine. Yeah. So here we've got three sequences. We've got our initial starting string. We've got string with leading, trailing, white space removed, and then intervening spaces removed. All those three things exist all exist after performing the consecutive operation. So if we now print my sec and str sec and cln sec, so we've got those three strings here. As you can see, all three are there. This is our starting string. This is string after stripping leading and trailing spaces, and this is after removal of the intervening space characters. So the point is that stripping my sequence string generated a new copy that we saved into strsec. My seq is still there, unmodified. In a replace, there's one. This is the character that we are starting with. Yes, it will. So if we want to remove all the spaces, then we can use replace without doing stripping and then replacing. Depending on the context, you might want do it one way or the other. It might be, for example, and we're gonna get to example just. Oh, because this is what we put in place of the first string. So okay, let's demonstrate this thing. So let's say that we want to replace empty spaces with colons. So then we would do it this way. Okay, and here we replaced every occurrence of a space with a colon. Oh, the thing here, I'm just making sure, I'm just printing it in a way which makes it easy to notice that there's no leading space. So you see, when I print unstripped my sequence here, I'm not exactly sure where the space here came from and where the space here came from. So I'm just putting something that's not a white space in front of my string and after it. So then if there's a white space, then I see it. So you see, so I'm just putting here colon plus and plus colon. This way, when I print it, I know that my string that I printed starts here and goes to here, and it's and this space was generated by print. It's just to make the printout easy for seeing the strings. So it's just useful debugging method or technique or whatever you call it. Okay, so as one of you mentioned, if we want to replace all the empty spaces, then we can just replace, start from my where is it, my sec, and then I'm gonna just print this, and then I'm gonna put this down. I'm gonna put something like this. Okay, and I've started with my sequence with leading spaces and spaces in between, and then removed all the all the spaces all together. But in some cases, you might want to keep the intervening spaces. For example, if I want to split this sequence into codons, okay, then I want to get rid of the leading spaces and trailing spaces because they are meaningless. But now those spaces in between can be used to split the string into segments. Let's see how it works. We can do it by just using the split method. So now we've got. Let's make another block. Let's start with our sequence. Okay, now let's strip it as before. Copy. Okay, so here's our stripped sequence, and now what we can do is we can do str seg. This is our stripped sequence. Now we're gonna do split, and as an argument, we're gonna provide a character that's gonna be used as or interpreted as a separator between the fragments. So let's split on empty space and see what happens. Okay, so as you can see, the result of the split operation is a list. Okay, and then the elements were generated by scanning the sequence, observing the empty space, which is then used to cut the sequence into fragments. So we're getting ATG as a first element, CAT as a second, and so forth. The character used for splitting is lost. So here's the example why we might want to retain some of the characters. Out of curiosity, what happens if we don't strip? Let's see what happens if we run it this way. Well, so now you see, here's a demonstration that sometimes we want to get rid of the leading space. The reason is that if it's retained, now the split operation is gonna interpret each space as a separator, but if there are leading spaces in front of the characters, well, there's an empty space separating those. So now those empty spaces are coming in as two elements here and two strings of length 0 elements at the end. This is because we've got two spaces. There is a string with no length in front of the first space. So this is this guy. Then there's a 0 length string in between two spaces. This is the second one, and only then we're getting ATG. So here's the reason for stripping first and then splitting into bits and pieces. We're getting rid of the artifact. Yes, so for split, that's how it works. That split is going to return me a list of the substrings as a list. Yeah, so that's how it works. It might work with one disclaimer, is that there might be a strip method used with other data types. Here we're looking at the strip that is defined for my sequence, which is a string. So as long as the variable here stores a string value, that's how strip is gonna work. Strip will have to take as an argument a character or a string that's gonna be used as a separator. If it's not there, then it's I think if split takes no arguments, it will split on everywhere. It's gonna split character by it's gonna split on space anyway. So split like this is working the same way, as split. So those two variants are equivalent. So and the result is always gonna be a list. I think the argument to split can be something else. Let's try it. Let's try to split on a cat and see what happens. Well, as you can see, you can split on not necessarily on a single character. You can split on something longer. Let's say we're splitting on CAT. The result is whatever was in front of CAT. So this is what we're getting up to here. The leading spaces are missing because we're splitting the stripped strsec. So we're getting ATG and space. Then there's a CAT that was interpreted as a spacer, as a separator. So it's not in a list, but then it's followed by space and the rest. So as you can see, we can split on the longer things. Okay, so that's the basics of operations on strings with a couple of extra things we've learned today. We learned about stripping, replacing, and splitting, I think. So that's and as you remember, we can always get the length of a string by typing len. There might be. Let's see. Well, the way to do it is to. How do I get? Well, I can. How do I do it? I can go to help, and we can try. How to get it? Well, let's try to cheat. Control I. Yeah. No. Well, let's try. Let's go here. If in trouble, you can always look for string methods Python. Okay, and string method string, and let's strings Python here, and then I'm looking for documentation for Python and common string operations, and then let's see what does strip say. But we can look for strip. Okay, and no strip. Oh, okay. If it doesn't, it should work. Let's see. String methods here. Okay, so let's look here. Format. As you can see, there's a lot of operations that you can perform on strings. I'm just going through things that are relatively common and relatively useful, but there's way more than those four. The way to get to those is to find documentation for the Python, and then you can get description of what is available essentially. So let's go to strip here. So with strip, there's nothing that you can do. You can't specify the range. With replace, let's see, with the replace. Where is it? With with replace. Okay, so with replace you can specify how many replacement you want to do, but you can't specify the range. If you want to change, if you want to specify the range, then you've got to figure out how to do it on your own. One way would be to convert the string into a list of characters and then write the loop going from position to position and then doing replacement by hand inside the loop. So this is one way to do it, but the first thing to check if there's something extra there is to get to the Python documentation. Is a good time to mention it. If you go to Python, this is the place where Python lives. Essentially, this is URL there, and then there's a documentation out there, and preferentially you go to docs, and then where is it? We should have Python docs. Okay, and then you're gonna have two links. The language reference is gonna describe the syntax essentially. So it's gonna describe how you what are the rules for building if-then statements or loops or things like that. The library reference is gonna give you information about functions and methods for different data types. So those are two places to look for. We're looking for methods for strings. Then we can go to built-in types. There's going to be strings, and here we've got common string operations mentioned somewhere here plus string methods. So with a little bit of patience, you'll be able to find a lot of stuff that might be useful. And the standard place is once more here. This is the offshore documentation for Python. Another way to find answers about Python is just to look for something like a Python string split, and you're gonna get tons of information there with different web pages providing information about different operations. So this might be quite useful. It's Google is your friend in general. Okay, so we went through splitting, and we covered most of the string operations that are common. Okay, now with lists, there's more options, more methods that allow you to modify lists. This is advantage of a list, that if we're working with lists, we can modify individual elements in different ways. So let's first make ourselves a list. Okay, and I'm gonna make it now a nice one without spaces. Okay, so that I don't have to split it, and then I'm gonna convert it converted into a my LST by casting it to list my set. Okay, so now I've got my LST that I can print, and here's our list of characters. This is because I created initially a sequence and then I coursed it into a list. So that's what I ended up with. Okay, so now if I want to add something to a list at the very end, I can use append method. Okay, and I'm gonna call it this way. I'm gonna call my list is my list variable. So I'm gonna append, and I'm gonna append triple X, let's say. I can append whatever I want. Yeah. Okay. So now here we're trying to append something to my list. As you can see, this method returns nothing. This is different than the methods we had with string. Every string method is going to return you the modified version of a string. The list methods will not return a value in general. Some might, but in general they might not. The reason is they might modify the list itself. To see what's the result, we can print my LST, and now we've printed out the modified version of LST after appending triple X here, and here it sits at the very end. So we modified our initial list. It also means that if you want to retain the original version of the list, you've got to think about it before calling a method that is going to modify it in place. This is most common for sorting. We can sort the list by calling sort. Okay, so here and bring copy, and we can now print the sorted version of a list. But you see, we printed out our starting piece of data, which after sorting is gone. The list is different. To get a copy of to get a new list that is sorted, but without destroying the starting one, we've got to use we've got to use list. We've got to use sorted function that takes my LST. Okay, and now if we print my LST, is gonna be okay. It's okay. So here's our my LST that is not sorted, even though we run a sorted, we call the sorted function on the list, and put that cancel. And here, if we print S list, so S list. So here we've got my LST still unsorted after running the sorted function, after calling the sorted function, and at the same time we do have the sorted version printed here. So there might be so not all the methods called on list will return a value. In many cases, the modification is gonna be done. The operation is gonna be performed on the list that we call the method for, without providing extra output. It depends on the method. For strings, there's always a return value for a method. So let's try what we can do besides sorting, which we had before, and appending. Yes, you can assign mylst.sort, but there's gonna be nothing there. It's gonna be non-value. We can do it. We can do something like x is let's see, my lst sort. Sure, this is gonna work. Okay, but now if we print x, there's nothing there. None, it means that there's no value stored at a given in a given variable. So sure, we can do it, but it's very uninformative, because what happened is whatever is sitting in mylst was modified. What we can do is we can assign. We can run mylst. We can assign then mylst to x. We can print x. Yes, it's there as a sorted, but it's exactly the same. It's exactly the same list as this one. By assigning a list to another variable, we're just creating two alternative names for the same piece of data. So for all the practical purposes, x and mylst are the same. If you want to convince yourself, we can, for example, do something like this. We can print x, then we can do x append y. Okay, so we appended y, and now if we print x, we do have y's. What happens if we print mylst? Well, we're also getting y's. You see, so assigning a list to another variable is just gonna create a new name for the same piece of data. So then it might be sort of confusing, because now you think that you appended y, 3 y's to an x variable, but you actually also appended the same, perform the same operation on mylst. Those are two alternative names for the same piece of data. So that's how it works. Okay, going back, I'm gonna get myself a block. So we went through append. To add stuff at the end of the list, we can do other things. We can try to find if there's some value in a list by, let's say, repeating what we've got here, and we can try to mylst find, let's say, t. This is gonna find us we can't find, because there's no find. We can't find things in a list, but we can. This is wrong. We can look for index. So in a string, we can find a character or a substring by using a find method for a list to find if there's a value that we're looking for, we've got to use the index method. And then it takes as an argument the value we're looking for. So in this particular case, we're looking for a value of t. Okay, and then if we print my LST, the first element with the value t is at index 1, so that's what our method is returning. Note that it's not telling you that there are consecutive t's farther up the sequence, further up the list. The index is going to return you the first occurrence of a given value. Index is, I think, allows you to specify which position you start from. So if we found something at 1, we can then, I think, say T2. And now index is gonna start looking for a value starting from element with the index 2. So now we're searching starting from G. So then we're getting T here. Found, and this is 0, 1, 2, 3, 4, 5. So that's what we're getting. We're getting 5 for the next one. So to find consecutive positions of consecutive t's, you'd have to write a tiny loop which would go through the string and keep searching, and it would keep searching for consecutive t's, starting every time from position next after the one that we found at the last time. And if something is not found, let's say if we're looking for lower case t which is not there, then we're generating error. So the point is that the value we're looking for has to be in a list. If it's not there, we're getting an error. So to protect ourselves from that, we can always start with a if statement and check if t is in our my LST. This is a way to check if a given value is present in the list, and then we can print the position. Okay, so here, I'm missing a bracket here. So here, I'm first checking if a given value is present in a list, and then if it is, then I'm looking for the index of it. Okay, so if I run it, now I'm learning that there's a t at index 1. If what I'm looking for is not there, I can just print not found, for example. And here the lowercase t is not present in my list, so the conditional statement drops the true part and goes to else and prints out not found. So this is how to find a value in a list. If we want to remove an element, then we can remove it from a list using the remove method. And so let's say my LST remove, and the remove is taking as an argument a value as far as I remember. Okay, and now print my LST. So let's see what happens. I'm gonna comment this thing out. So now I'm printing my list, and then I'm removing capital T, and then I'm printing it once more. Yes, I'm gonna get to insert once I'm through removing things. So let's see. So here, remove is gonna remove you the first element with the value we're asking for. So remove is gonna remove T, and it's gonna be the first one. So only this T is gone here. The consecutive T's are still retained. So remove is going after first occurrence of a value. If you want to remove an element at a given position, not of a given value, then you can use a method called pop, okay? And this is a method that will return something, okay? Let's look at it. So let's say my LST pop, and let's remove an element with an index 1 once more, okay? And then let's print my LST once more, okay? So what we've got, this is our initial string printed here. Then we removed the first occurrence of T and printed it out. This is the second line. And then we removed the element at position at index 1 and printed it once more. So now we removed G, which was at this moment at index 1, and now we've got AC. So we removed G here, so we go AC. Now, when we're popping elements in the given position, it might be useful to know what was there. With remove, if we remove T, we don't have to be curious what we remove, because we know what we remove. We don't know where it was, but we know what it is. With pop, we're removing something at 1. It might be useful to actually get hold of it. So what we can do is we can just assign the value returned by pop method to something. Let's say L here, and then if we print element in my list, now we do have the element that was removed here, and this is the list after removal. So this G is now returned by pop. So here's an example of a method that works on a list that actually returns a value, but this is not guaranteed. We had a couple of methods that didn't return anything, just worked internally on a list. Okay, so this is how get rid of either a specific value or a element at a given position. We can insert something if we want to add element at the given position. We had append that was adding at the very end. Let's see if insert works. Let's try my LST insert, let's say x at 1 or 1 in x. Yeah, so we've got to insert at position 1, and we want to insert x. And now if we print my LST, our insert method takes 2 arguments. The first one is index, where we want to put the new value in, and then we've got the value. So insert 1, x is gonna insert x at the position 1, and whatever was at 1 is shifted one position to the right. So entire list becomes longer by 1 element. So this is how we inserting at an arbitrary position. So here's the answer to the most recent question in a for remove there's no index. Remove is removing a given value. So this might be confusing. Remove method means remove the first element with the value t. Okay, and we don't specify the position. We're looking for the first element with exactly the value we're asking for. To remove element at a given position, at a given index, we've got to use the pop method. And pop is taking one argument, which is an index of the element that's supposed to be removed. So those are two sort of complementary operations. One is taking the value that is supposed to be removed. The other one is taking the position of the element to be removed. As a bonus, pop gives you the value that was removed as a return that you can either print or assign to a variable. So those are the extra operations on the list that we went through. Okay, and I think we went through sorting and sorted, and this covers the basics of lists and basics of strings. We've got one more method, one more data type to go through, which is new. It looks sort of like a list, but instead of using numbers to index values, it's using arbitrary pieces of data. The common application is common use is to use as so-called keys strings, and then for each key we're associating a value to it. The way to create dictionaries is shown here. What we do here is we're creating a dictionary. We know it's a dictionary, or Python knows it's a dictionary, because now we're using curly brackets, and curly brackets means we want to create a dictionary. If we want to create an empty dictionary, we do cdict, and this is gonna create dictionary with nothing there, just empty dictionary. If we want to create a empty list, then we would do clst. This would create an empty list, a list with no elements. Here we're creating a dictionary with no entries there. To create a dictionary with entries, we put pairs of a key and the value separated by commas, and key and value is separated by a colon. So here we've got a dictionary with 4 entries, 1, 2, 3, 4. Each entry is a pair, key and a value. To get a value, we use as an index, we pretend the key is an index. So to get the value corresponding to key, that's A, we just do C dictionary A. Okay, and this is gonna return us the value that is associated with the key of A. So we're asking for A key, and the value returned is coming here. And the same thing for the other values. We can ask for value corresponding to T, or we can go after value corresponding to C, to C. So this looks sort of like a list, but we can use now arbitrary type of data to use it as our index. and then retrieve it, retrieve the values using those. Now, with lists, we know we can check what's the length of the list, and we know what are the valid indices. If a list is 10 elements long, we know the valid indices go from 0 to 9. For dictionaries, whatever is used as a key is arbitrary. We can put any piece of data there as a key. It's perfectly fine to say something like dictionary, let's say true, yes, and false, false, no, and then we can every time you've got the true value, we can retrieve yes, and every time we've got the false, we can retrieve no. So we can use anything in a dictionary. The problem with that is that we don't know beforehand if a given key is present in a dictionary. If you remember with lists, if we used index bigger than the length of the list, we're generating error. Here it's gonna be the same. Here we'll have the same problem. Here if we try to do C dictionary, and if we try to retrieve, let's say, a key that doesn't exist, we're getting a key error, which means that dictionary we're trying to find the value corresponding to our key doesn't have this entry. So to check if key is present there, we can just use an if statement and check if a given key is in our C dictionary, and else print no. Okay, so here we don't have an error. Program works and tells us that okay, we're missing the key. If the key is present, let's say we ask for capital A, C dictionary, if the C dictionary of A, like here, now print, and we've got to print. So here, if a key is present in dictionary, we're printing the corresponding value. If it's not present, then we're printing something else. So to check if a given key is in a dictionary, you've got to we can check using in. This is similar to other uses of in. We can for example check for strings if a given character is present in a string by using in operation. So here the meaning of in is we're checking if a given key is present in a dictionary. If we want to get entire the list of all the keys in a dictionary, we can just print C dictionary keys, and the method keys called on a dictionary will return us a list of the keys. So here are the keys that we've got here. In general, it is not predictable what will be the order of the keys in a list. So here it happens to be ATGC, and it corresponds to whatever we've got here. But in principle, it's hard to predict what's gonna be there. as far as, and I think it's changed. It used to be changing between different versions of Python. I think the current situation is the order is the result of whatever operations were performed on a given dictionary, and it might be arbitrary. If you want to have a control over the key order, you can always sort the key. So if I do sorted, now I do know that no matter what happened before I called this print statement, my keys are gonna be in alphabetical order. This might be whatever one wants, might not, but dictionaries do not return keys in a predictable way. At least this is the safe thing to assume. So that's how to get either, this is how to check if a key is present, or this is how to get, yes, you can yes, and if you make dictionary with keys being integers, then you're gonna confuse the hell out of everybody. This is a way to make something which is very obfuscated. Sure, you can use integers as entries in a dictionary. It would look suspiciously like a list, but then every now and then it will misbehave, because, for example, it might have certain values missing. You might not have a key set to 2, but you'll have keys of 0 and 1 and 7 and whatever, and then you're gonna confuse nearly everybody there. So using integers for keys in a dictionary is probably not the best thing to do, but it is possible. Sure, programs are it is very easy to write programs that are very confusing. So this is one of the good ways to make things confusing. So let's see. So we went through finding if the key is present. We went through getting a list of all the keys. If we want to add a new key value pair, we can just use an assignment. Dictionaries as lists can be modified, so they are so-called mutable. This is different than strings. Strings are not mutable. Strings are immutable. Here we can modify. We can modify dictionary. We can, for example, say, let's get this thing here. So here's our initial dictionary. Let's do C dictionary. Let's say we want to have an entry for a lowercase a and set to also lowercase t, like this. So here we've got we're asking Python to assign value lowercase t to a key of lowercase a in a C dictionary. Okay, and once we do it, we can print C dictionary, and now we've got one more element here that we just added. If we want to modify the value for a given key, it's perfectly fine. We can just modify it here and print it once more. And this is our dictionary after adding the key value pair, and the key is lowercase a lowercase t, and now we decided, oh, we want to put uppercase t as a value corresponding to lowercase a. So we made a modification, and here's the modified version. So with modifications of values or adding key value pairs in dictionaries is relatively use colon. No, this doesn't matter. I use this thing interchangeably. This is either way. What it means is I want to use a string with the value of lowercase a, so it doesn't make any difference. This is exactly the same as this. And first convince yourself that if that's the case by checking if a is equal to a, and here's the answer. That's right. You can see that those are exactly the same things. Why are both a and t's up values for instead of just I'm confused. Both a, not, you've got only one value for a given key. There's no way to put more than one value for a given key. So a and t as values c's instead of, well, we're getting uppercase a as t. Yeah, so I put capital T as a value for lowercase a. So we're getting capital A as key and lowercase t, and then we're getting lowercase a and capital T. This is always key and value. Okay, so this is how to either add another key and value pair to dictionary, or how to modify already existing value to get rid of a key value pair. We can use pop. It's similar to whatever we've got the list. So let's try it. Let's get the dictionary. Okay, and let's try C dictionary pop. Let's pop capital A. Okay, and then print C dictionary. So pop is gonna remove us the key value pair where the key is capital A. So that's what we're missing now. Okay, if you want to learn what was actually popped out, it's gonna be the same thing as with popping out element at a given position with lists. You can just see what pop a returns. So we can actually do print and print then C dictionary. When you've got a function call like this with more than one argument, okay, then the arguments are processed in a sequence. So what happens when we're calling the print function is the interpreter will first yes, that's the idea, exactly. That's for reverse complement. So if there's a function with more than one argument, the arguments are processed in a sequence. So first, this is gonna be processed. To generate the value to pass to print function, we've got to call pop on a C dictionary. Okay, so that's what the Python will do. It will run pop on C dictionary. which means that C dictionary is gonna be modified by pop, and then we need the C dictionary passed as another value, as another argument to print. So this C dictionary is already processed. You will see it when we run it. We're getting lowercase t returned by pop, printed out, okay? And now we're getting C dictionary with 80 pair already missing. So here we've got the modified dictionary. If we want to print out unmodified and modified, we can call C dictionary here, okay? And when we do it here, it's still not gonna work. Why? Because C dictionary is the same thing. Print got the information where to find the value for C dictionary, okay? And this value was modified when we were calling pop. So all those three things are exactly the same, and we're getting the first and the last argument is exactly the same. It corresponds to modified version. So so that's how things behave. The point is that we can print out the pop the value and then modified dictionary here, or we can do it separately. So that's how to remove a given key value pair. And then the last operation is to recover the list of the keys. We can iterate over dictionary with as with strings of list. It's gonna be similar. We can do for k in, and let's k in C the simplest thing is to simplest thing we can do is we can check what the for loop is gonna set us in k, and we can print k, okay? And as you can see here, we're getting value, we're getting keys from the from this statement. So k is set every pass through the loop to one of the keys. Once more, the order is not guaranteed to be whatever predictable. So it's better not to assume anything about the order of the keys returned. You can always, but you can sort it. You can use sorted method to get the keys sorted. You see the order here is whatever, but the order after sorting is alphabetical. The way this thing works is obviously we're sorting the list of keys returned, list of keys that goes into the loop. So so this is how to get key, and if you want to print out the value, we can always do C dictionary and then ask for a value. Okay, so now we've got one column of keys and then another column of values. And that's the basics of dictionaries. They are very similar to lists in some ways, but they allow you to use meaningful labels, meaningful keys, and then associate them with values. And there's no restriction on the types of data that can be used as keys or the values. For keys, it's better to use values of the same type, because if we try to mix types. Let's say we put one of the keys as integer, all the other as strings. If we try to run it with sorted will try to order the keys, and we've seen yesterday that we don't know what's the order, how integers and strings are ordered together. We can sort only within strings or sort within integers, but we can't sort integers and strings together. So this thing is gonna generate type error, and because of that, it's reasonable not to mix types for the keys. So it's better to have keys as strings, or as most commonly they're actually strings. So sometimes this use with the true false might be useful if you want to provide meaningful strings printed instead of true or false or something like that. But the types of the keys should be similar. Okay, so this covers the last data type that I wanted to go through, and then we've got one more variant of a loop to go over. So far we're using always the for version of the loop, which was taking a piece of data composed of one or more elements, and the loop was going over all of them. In some cases, we might want to go over a list of things, list of values in a list or in a dictionary, but we want to we want to go through the list of characters in a string, but we want to stop at some special character, for example, and then we want to get out of the loop and keep going on. We don't want to go through all the characters before getting out of the loop. So one way of doing it is to use so-called while loop. Okay, I'm gonna modify it here. To use it, we've got to first while. Well, so let's start with a simple example. Let's set as a variable to true. So now we've got a variable which says that's set to true, and now we're gonna write the loop starting with the while keyword. Okay, and the while is checking what's the value of the expression here. Our case, we've got just a variable set to true. Okay, and then if the value here is true, then the block following while statement will be executed. Okay, once whatever is indented past while was executed, then the Python will go back to while. It will check condition once more, and then depending if it's true or false, it will keep going through the loop or not. So let's see what happens here. Okay, so let's run this thing. As you can see, what happens is we set condition to true, we run through while. The condition was true, so we printed I'm looping. Then we set condition to false. Now we went back to while. Now condition is false, so we went out and terminated the loop. So we've got only one I'm looping printed out. What happens if we start with condition set to true to false? Okay, if we set condition to false to start with, then nothing happens. The initial value was false, so while didn't go inside the loop, we just skipped everything altogether. Another curious case is starting with condition set to true, but then not modifying. Well, if you want, well, then you say not. You say not conditional, and then it's gonna be reversed. Whatever goes in after while is an expression. So here's a rather artificial way where I do have a hardwired variable used here, but in a moment you'll see it can be an expression. So if condition is true, okay, but we don't modify it, okay, at all. If we try to run it, we're getting diarrhea. This is gonna go forever. This is gonna go forever, because to stop it, you've got to press Control C, and we're gonna end up running it. What happens is, well, we have condition set to true, then it's true, so we're printing stuff. There's nothing else to do, so we're going back to while condition, keep going, and we're gonna go forever. So the danger of the while loops is that they will never terminate, because we never modified our condition to make the loop stop. So this is something to pay attention, and in some cases you'll see, as you've seen just moment before, diarrhea of things here, and then you've got to stop the your program or whatever is running in the console in a spider, and figure out why damn thing doesn't stop. It happens. Nothing to be worried about, except that you've got to find out how to make sure the loop terminates. So this is very artificial. This is a very artificial example, just to show you how while loops operate in a very simple cases. In more realistic case, here's another case. Let's say, let's do it this way. This is more interesting. So let's start once more with the sequence, okay? And let's say we want to count how many characters is there until we hit a star, for whatever reasons. First, we've got to have a counter. We've got to have a variable to store the number of characters we're going after. Okay, so this is gonna be our counter. Okay, initialized to 0. Okay, and then this is current index, sorry, not counter. And this is gonna be our counter, and let's do count 0. So this is our index that we're gonna start with, which is gonna be 0. This is gonna be our counter. We're gonna count how many things is there. Let's say it this way. I'll complicate it a little bit. Okay, so now we're gonna start the loop. Okay, and our condition now is an expression. Our expression is checking if the character at the current index is different than star. So if index is 0, we've got A. So we're gonna go into the loop. We can print it here. Okay, we can just for our curiosity to see what's there, and we can increment now the index by 1. So now during the second pass through the loop, we're gonna look at the second element in a string once more. If it's different than star, then we're gonna print it out and increment stuff. And let's say that all this time we're interested in looking for C's and G's, for example. So let's say if our is C or my is G, count plus 1. Okay. Okay. So here's a more complicated version. We're printing out one character at a time, and then we're checking if this character is either C or G, and if it's one of them, then we're incrementing the counter. Okay, and then irrespective of the match, we're gonna increment the index to go after next character while looping. And once we hit the star, we're done. Okay, we're gonna print empty new line, because here we're not printing empty lines, so not printing new line. So I've got to print the last new line after last element, that's the last character that I've printed. And now I'm gonna print count. Okay, and let's see what happens. And I can CG count. Let's see something like this. Let's see what happens. Okay, so what happened? Well, we went over characters in our MySTR up to the star. Okay, this is how the characters here were printed, one at a time. Every pass through the loop corresponds to single character printed out here. If when the character was either C or G, we incremented the count variable. Okay, and when we are going through the loop, every time we are done with doing our business here, we incremented the index to go after next character in the next pass. And once we went out of the loop, we printed a new line to go one line down, and then we printed out what's the counter. So it means we should have 1, 2, 3, 4, 5, 6, 7 C's and G's in a string up to star, and that's what we've got. So here's a simple example of a while loop where we want to terminate looping before scanning through entire sequence or entire list. We can through entire dictionary, we can easily jump out, terminate the loop when certain condition is fulfilled. The danger is, though, that this condition might never be fulfilled, and then you might run into trouble of a loop that runs forever and never terminates. So that's the last statement type that we're gonna go through. Okay, and this covers practically all relevant statements and data types in Python. This is gonna get you quite far in terms of writing your own scripts. You've got all the basic data types. You've got all the basic statements. So you're gonna get better when writing code and struggling with initially syntax errors, but you've got the basic knowledge. And I've tried to restrict myself to constructs that are common to different programming languages. So I didn't introduce any Python specific things. At least I was trying to limit those so that most of the information you got here is transferable to C, C++, Python, Perl, Ruby, whatever, PHP, whatever languages are there. There might be slight differences in a syntax. You've seen 2 days ago questions about curly brackets and things like that. So there are differences between different languages, but the ideas behind the data types I introduced and the statements I introduced are common to all the languages. So there's no specific Python things. There are constructs in Python that lets you write shorter code for certain operations, but there are specific to Python, so I was staying out of those. Now, there's way more than what we've got here. In terms of additional functions that are available, additional data types they are available, and those are in general not used all the time. So to get access to those, we've got to import those from so-called modules. Modules are not mysterious. Those are just snippets of Perl code that are sitting in some file somewhere where Python knows about those snippets. And if you want to use functions in those snippets of code, for example, you've got to let Python know that, oh, you're interested in a certain module. To do this thing is we're using well, without star, it will work. It will work. It will work very efficiently. String in the well, it crashes because it keeps looping until the index is is equal to length of the string. So at the very so it prints everything that's there in a string up to GGT, up to GG. Okay, this is message up to GG. Then we keep looping, and we're trying to get my string with index equal to length, and then we're getting information strings is out of range. So that's the problem. So this is the danger with while loops, that if conditions not fulfilled depending on circumstances, you might either get an error like this, or some operation is not valid, or you might never terminate. So those are two possible problems with while loops. Okay, so if we want to get this extra functionalities, extra access to extra things, we've got to ask Python to import information from some sort of a module. The simplest thing I can come up with is a math module. It provides access to additional math functions, essentially, and constants. To get access to those, we say import math, which means get our math module, and then once we do it, we can get access to functions like square root, okay, and we can run it, and we're gonna get a square root of 2, which is exactly the same as 205, so there's not much gain here. This is exactly the same, but we do get access to exponential function, for example. So let's comment this thing out. So here this is e to the power of 1. Get rid here. Okay, so this is Euler's constant here, or we can have it squared, or we can inverse of a square. So this is a regular exponential function which without import is not available. There's no operator, there's no equivalent that us, unless you do have the, unless you do something like, well, in principle you can do it by hand. That's right. In principle, you can do this. That's right. You can do something like this. That's right. But it's easier to use a built-in function rather than doing these things as hand. So here's additional useful function to be able to access. There's no equivalent, no matter how hard you try to get the log. So to get the natural log, you've got to import math, and then there's a log function. This is natural log. This is not base 10. We can convince ourselves it's natural log by doing math exp 0. This should get us back 1. So that's we're dealing with natural logs. Apparently, we do have access to constants. We've got the pi. So this is the simplest module you can think about it. More interesting module is dealing with so-called regular expressions. This is something which is very, very useful. I'll go very briefly through it because there's a lot of details there, but there's no time to go through all the details, so I'll show you just the simplest application. But there's a pretty detailed description in the documentation. Here's a URL to corresponding page in a Python on a Python web page. I also included a short cheat sheet in the files. There's where is it? There's here this PDF file with short description of the regular expression syntax. But what those are, we can just go through here. So first, to get access to those, we've got to import another module which is called RE. And once we've got imported, we've got access to additional functions. The one that we're gonna use is called find all. To call it, we call it by using the name of the module followed by the name of the function. So this is the same as here. We're importing a module, and to access a function or a constant or whatever is provided by the module, we use the name of the module followed by whatever is provided by the module. So same thing here. Our function is gonna be called as RE. This is coming from the name of the module followed by the function name. Okay, and what the function takes, it takes 2 arguments. Okay, the second argument, at least in the simplest version, second argument is a string. So here's our string. Okay, and now let's say I want to find, I'm interested in every occurrence of GC followed by something, whatever arbitrary character is there. I want to get 3 characters. First 2 of those are supposed to be G and C. So I can specify so-called the regular expression or a pattern that will be matched against our sequence, and every time the match occurs, I'm gonna get another. I'm gonna return whatever was found. Okay, so to specify that I want to see G, C, and arbitrary character, my regular expression is composed of G, C, and then dot corresponds to any character. So whatever, this is like a wildcard. Anything can go there. Okay, and if I now assign the result of find all yes, if you want to convert between logs or exponentials, then you scratch your hand and multiply logs or exponents by something. So there might be in, I don't remember, there might be a base 10 log and provided or built in, but conversion between logs is just it's a constant. So here we're trying to find all occurrences of GC and something in my sequence, okay? And the find all returned as GCT and the GCA. So there are two cases somewhere within our string where there is a GC, okay? So here's one GC here, and this is returned here with third character being T, and then there's GCA, which is apparently here. So as you can see, the regular find method applied to a string requires exact match. Here we can specify that, oh, we want 3 characters with third one being anything. So if we add GC here now as another pair here, this GC is not gonna be found, right? Because there's nothing following GC, so the pattern doesn't match. Here I provided a short list of what's possible to stick into your regular expression. For example, if we want to restrict the match at the third position to only G and A, okay, then we can specify this way. We can have first character must match G, second character must match C, the third one is either G or A. If there's a square brackets with the list of characters in between, it means either each one of them is fine. Let's see what happens. So now if we run our match, we're getting only GCA found because GCT, which we had before, does not match our regular expression anymore. So so here's another example of regular expression. If we want to find, let's say, something that matches at the very end of a string, we can use a $sign to match the last, to specify expression that's going to be applied only to the last characters of the string. So let's say of a string. So let's say we want to check if there's a trailing GC out there, and let's see what happens here. Yeah, so there is a trailing GC. It's got to be trailing because the last character in the regular expression is a $sign anchoring the stuff at the end of the string. If we are to look for things that start the string, then we can put the caret, and this would match only when the string starts with GC. Okay, so this is exactly the same as starts with GC. This is equivalent, but if we want to put some more rules, more complicated if we're looking for something more complicated, let's say we're looking only for AT and then G or C. Okay, now this thing will match. Okay, but if this thing will not. So this simplifies searches through strings, because you can specify expression to your taste, and then you're gonna be able to run a test in a simpler way than writing complicated loops to trying to analyze strings on your own. So regular expressions in general simplify splitting text or finding motifs in a text, and in this context they are very useful. Here the assignment returns you whatever was found. If we don't care how many occurrences and what exactly the patterns are, we can use find all as just a test to find if a given pattern is present or not, by just using it in an if statement. Okay, here when a match is present, the find all is gonna return a list with one or more elements. Okay, and we're gonna get the match. I'm not gonna print this thing, but if there's no match, so let's say if we're looking for something like this, which does not show up there, then we're not got match printed because the condition is false. Why? Because if we've got an empty list, empty list evaluates to false. Okay, and if list has something there, no matter what, it's gonna evaluate to true. So the find all can be used to find if a given pattern is present in a string, and then you can make your program decide what to do with it. If you want to know what are the patterns, you can analyze whatever find all returned, what's the list of patterns there. If you want to get where in your string the patterns are showing up, at what position, there are more methods in the module. You'll find a lot of details in the documentation, and then you'd be able to find and list, enumerate all the occurrences of a matching strings in your matching patterns in your string. So that's something which is very useful in many contexts. It's worth knowing how to deal with regular expressions. It makes your life much easier. Initially, it might be kind of might look kind of complicated, but with time, writing those patterns comes pretty easily. So that's example of useful module. One more thing about the modules is that, as you see here, prefixing functions or constants that came from a module might be tiresome if we do it in our regular way, our initial way, where we import entire module. Then to access the elements, we've got to use the prefix and then function names, which makes us retype the damn prefix over and over again. Right? This thing works perfectly fine. Here we're getting pi, here we're getting square root of 2, but we've got to type math over and over again. So there are two alternatives. If we want to get only pi and nothing else, we can import just pi from math module, okay? And a bonus is we don't have to specify type math anymore. Once we write from math import pi, we're getting pi constant without prefix. So I'm gonna clear all the variables here and clear the console. Okay, and if I run this cell, I did get pi here, but I did get an error. Okay, I will get the error even though if I do math. Adding math doesn't help. Clear. Okay. This will still generate error because math is also not defined. Well, the reason is the import in this form gets me only pi as a new thingy that I can use. I'm not getting access to entire math module. And that's why the second print is generating error. If I want to get everything from math, but still don't want to deal with prefixes, I can use the third variant, where I'm importing from math, but this time I'm using a wildcard, so I'm importing everything. Okay, and then if I use this format, I can remove variables, control, run, and now we're happy. Okay, so if I want to get something in between, let's say I want to get only pi and log, I can import more than one element from math to get hold of just selected parts of the module. And now this thing will also work. Remove our variables here. So this way I got only two, but then the exponential function will not work. So those are the three variants of the import. The reason for restricting things that are imported is that there's a chance that whatever you import will use the same names of something in your code, will collide with the names of the variables that you're using in your code, and then you might see some extra artifacts. So in general, it's preferred to import only those parts of the modules that you anticipate to be using. Otherwise, there's a danger that something funny will happen and it might be hard to trace. Okay, so now so far we're running things as cells in a spider. That's right. I had just one file. I was going somewhere inside one of the cells. I removed everything, cleared console, and Shift Enter was executing just this snippet of the code. This is not how normally Python programs are run. Normally, what is done, you do have a console somewhere open, text terminal. You type Python, you type Python. This is the name of the Python interpreter, and then you pass it the function. Let's say my script Py. Then you pass to your interpreter the name of the file with your Python script, and then you might pass some arguments, let's say name of a file, that you want to process with your script. Let's say this sars and sec. So this is typical way of running scripts. You specify that you want to run a Python program or script. You provide the name of the file with the program, and then you might provide one or more arguments that point to the data or specify what operation you want to perform. So how to do it within Spider? Well, first we need a file with a script. So let's create myself a new file. Let's see, file. Let's make a new file. Okay, and I'm gonna get rid all of that, and I'm gonna get myself something. Let's get myself. This is good. Good enough. Copy, and then. Okay, so here's my snippet of Python that I want to run. Okay, so what I'm gonna do is I'm gonna, just in case, save it as, and I'm putting it into the same directory as all the other files. So this is gonna be my test script. Okay, test. Okay, and let's save it. Okay, so here's my script. Now, to run it, we go to the run button. The first time you do it, it's gonna pop up window with run settings for this test script. I would check that I want to execute it in an external system terminal. It means the Spider is gonna pop up another window where the output of the program is gonna be run, and I prefer it. If execute in current console would run it here, but I like to run it as a separate terminal. So I'm checking separate terminal. Okay, and I do check interact with the Python console after execution, so that once program done, it's gonna keep the window open. So this is second thing to check. And then the third thing is I'm setting working directory settings. It shouldn't be. So let's see. So and third one is I'm checking the working directory to the directory of the file being executed. So those are three things to check. Okay, and then run it. Okay, and here's what I got. So this is the text console after the program was run. Let's see why you can't run it. Let's see. So you do have a file with the script. Okay. Yeah. So you do need .py. Okay. Good. So now run after setting those parameters initially will pop up the window and show nothing. This is because this program doesn't print anything at all. So that's perfectly fine. And we've got the prompt from the interpreter blinking here. So let's kill it once more. If you want to change the settings for the script, yes, I'm just going there. So if you decide after a while that you want to change options for a given program, you can, instead of going on the run button, you can go on the run here and then go to configuration per file. This is gonna pop you up once more what you've seen at the very beginning. And now we can modify things. Here's the name of the full name of the program. Okay, it includes the full path to where the file is. So this is, I'm running it on Windows, so I've got C:\, capital user / my name, desktop, whatever. This is path to where the file is sitting. If you're using a Mac, you most likely is gonna have a /user/ your login on a Mac / wherever you put your file. I'm not sure how to find this thing in a. You've got to be able to find the script, find the files using the full path. I'm not sure how to find it on Mac. On a Windows, if you open a directory, then at the top it shows you the path to the directory you're in. So then to get to a file, you go / and add the file name. So that's how to do it on Windows. On Mac, I'm not sure. Okay. Anyway, the settings for a file should be, once more, execute in external system. Okay. The directory of the file being executed is working directory. Okay, and then for external system terminal, interact with the Python console after execution. If this thing is not checked, okay, and if you run your program, you're gonna see the window blinking up and disappearing unless there's an error. So to make sure that you still see the output from a program, you've got to go to run configuration per file and make sure that you do interact with the Python console once you're done. And now we should be fine. Okay, so that's how, and this is equivalent, once more, to running from a command line Python test script py. Okay, this is exactly the same. When modifying those files and trying to run them, you've got to make sure that the file is saved before you try to run it. The editor might try to do it for you, but I'm not. Oh yeah, the file actually got saved. You see, when we modify the file, the star shows up here, which means the file hasn't been saved, has been modified after last save. But when we try to run it, the star disappears, so it means the file got saved. So we're fine. Okay, so this thing doesn't result in any output. So if we want to see actual output, let's look for a piece here. And now if we run it, we do see what's printed out. So all the print statements will result in something printed out on the screen. Okay, so that's how we run scripts. Okay, it's still sort of tedious, because if we've got different types of different pieces of data, we've got to put those things directly in the program. That's right. This thing is going to run the same way no matter how many times you run. So if we've got different types of data, different data to analyze, we'd have to paste it into our program. So it's useful to be able to pass something to a script as an argument, some information. Let's say what file to open, what to do, or whatever to do. This thing is, we've got to be able to get to whatever is provided as so-called command line arguments. So let's say sars and sec here. Okay, so I want to let the test script py know that I want to work with a file called sars-nsec. Okay, how to get to it? Well, there's a module for it. there's a module for it called, and it is here. Okay, so let's go here. Yes, it's preference. You can run it in a console. I normally work on a text consoles over and over and over again, so I prefer to see a text console. But it's a matter of personal preference. If you let it run in a console, you're gonna see output here. It's just matter of taste to some extent, and I prefer to run it in a console because then whatever I see in a console while running in Spider is gonna look the same as when I'm working on a text terminal outside of a Spider. So there's less variability between different ways of running things. So that's the reason. And where's my last module? I've got the module here. I'm just making sure it's in a script here. Modules math. Oh, I says, well, okay, it's not here. Okay, import. I think we got to import sys and then print. Print sys okay, let's see if this thing works. Okay, so let's try to go after the command line argument provided when running the script. To provide it, we've got to actually modify our run settings for this file. Okay, and there's gonna be an option here, command line options, and I'm gonna put this sars n sec down here. Okay, and then let's try to run it here. Syntax error, corona file line 1. No, doesn't do. File source genome, no. Oh, because I'm running the wrong, no. Oh, what's going on? Let's see, test, import, print, this should, let's run it. File, now what is it doing? Print, that's what did I do? Something's funny happening. No. No. Conf test run options. No, that's the wrong play. Just run their command line. Yeah. No. It doesn't go here. Remove, no, working, execute. How do I pass? Run console, now execute. Remove all variables directly, enter, and command interact. It should work. Syntax source, why is it? This is mysterious. Why is it? No, this is Python. The script. This confused the hell out of me. Run console directory, working the following command line, remove, interact. Let's see, get rid of this thing and run. Okay. Now this is okay. Configuration profile. and then command line options. No, script pi. Let's see. Run. No, this hates me. Run. This is not command interact. Why is it confusing me? No. No. Sync is well, I'm trying. Well, at the moment I've got problem adding anything as a command line argument. Okay. See, this thing works fine. Oh, let's see. Test script. Let's see. It's telling me what is. Let's try once more. Run configuration per file. Let's try A, B, C and see what happens. System. What was it? Can't A, B, C, no such. Python. Why is it doing this? Run configuration per no, execute external, remove, run directly, enter general. Well, okay, let's see if maybe I'm supposed to get it here. Let's say ABC here. Okay. No, and now run. Oh, good. That's what I want. Okay, so that's where to. This is always confusing. Okay, so the proper setting is console execute external. For general settings, command line option is checked, and then something goes there. Let's put there our sars -n sec. Okay, so that's where the command line option goes. Okay, working directory is the same as the file being executed, and then we interact. Okay, so now let's run it. Okay, there's nothing here because we're just importing sys. So now let's uncomment print sys argv, and now print it. Okay, and now what you can see here is the print sys.argv printed out a list. Okay, the first element is the name, the full name of the script. So this is including path. So this is where my file is with the script is sitting. And then the second element is whatever went as a command line argument. So I specified sars-n as a command line argument. So this is what we've got here as a second element. If we got more command line options, then if there's gonna be, and it's gonna be, let's say, triple X and triple Y. So now we've got 3 of those. If we run, now they're added and the list is becoming longer. The point is that we can get hold of what was passed on a command line argument to the script by importing sys and then looking at sys.argv list. The first element is going to be name of the script, including the full path, and then if there are command line arguments, they will be provided as element with index 1, 2, 3, and as many as is there. So let's get. Well, then you run, if you don't run spider, then your script is gonna be run like this. And you'd have to open a console and then type Python and then name of your script and then command line arguments. This how it will work on a Mac and Linux of any sort. With Windows, it might be more messy. I'm not exactly sure, and it will take me a time to figure it out. So I'll try to write it down in a file for today, how to run Python in a standard way on Windows. With both Mac and Linux, this would work. The Python is the name of the program that runs the interpreter, and then you've got to feed it with the name of the file with your script, and then you provide one or more command line arguments there. And the way to retrieve them is you import sys module, or you can, if you want to make it simpler, if you want to get only argv, you can do from sys import argv, and now we don't need sys, and we can print only first argv with index of 1. 0 is gonna be the name of the script, which we don't care. We know what the name of the script is, at least at this moment. So let's try to run it. And here we've got the file name. We can make it look nicer. We can print sec file. Sequence file, and if we run it now, we've got the output from our print statement, and we know what's the name of the file. Well, name of the file is pretty useless if we don't know how to read files. So we're gonna finish up with reading files. Okay, so let's go back into Spider, because it's faster to deal with this thing. Also does. Yes and no. If you create a new file like here, then you're getting this additional stuff that shows up here. It's all interpreted here as commands. So the first line looks like a command because it starts with a hash, okay? And then the second line is yet another way of specifying strings. So this is just a string started with triple double quotes. And what it means is the string starts where the cursor is now and goes all the way until the paired triple double quote. So this is a way to entering strings with new lines. So this is essentially a line that's a command, and so this will not change anything. Whatever else, if you see things like this user being Python. If you see some Python, something like this, you'll see it only if you're on Linux or maybe on Mac. And it simplifies running scripts by when you're clicking on things. So this will have no effect if script is run like this. It's gonna be treated just by interpreter. Interpreter is gonna be treated as a regular script. This is gonna be treated as a regular command, and nothing will happen. So there's no problem. I tend to, at least when playing with Spider, I tend to remove those things so they don't go in a way. Okay, so going back to going after files. Okay, so where are we? Okay, so let's let's first look at what's sitting in this file. So I've got it here. Okay, this is a file with a fragment from a COVID virus, actually. Okay, just for fun. And this is standard way or semi-standard way that sequences are provided. There's a line. The first line is starting with the greater than sign, and there's information what it is the sequence of. Okay, and then there's one or more lines with actual sequence. There might be spaces in between. They might be of different length, but all of them all together correspond to a sequence of either DNA, RNA, protein. The general name of the format is FASTA or FASTA, referred to as I guess it's called FASTA format. And this is probably most commonly used format for dealing with biological sequences being either nucleic acids or proteins. So that's what we've got to read. And the goal is to get the sequence into a single string variable. Okay. So first we've got to make ourselves an empty string that we're gonna start adding what's coming in from the file. So this is gonna be our sequence. Okay. Now to start, I'm gonna go here. I'm too far. So here's my sequence. Okay, that's for a moment empty. Okay, and I want to start filling it in with information coming from the file. First, I've got to open this file to let script communicate with the hard drive and start reading information from there. To do it is we say this. Okay, we use an open function. It takes two arguments. One is a name of the file. Yeah, just a moment. Tools, preferences, and then general appearance. Okay, this should. Oh, okay. Come on. Okay. Oh. Okay, good. Here. Is that good enough? Hopefully. Okay, good. So you should have screamed earlier. I would make it bigger. Okay, so this is our sequence our variable that we will use to fill in with the sequence coming from the file. So I initially make it empty sequence. I can do it single quotes if you prefer. It doesn't matter. I want just the empty sequence. Okay, to start reading, we first got to open the file. The way to do it is to call the open function. It takes two arguments. One is a path to where the file is, okay, or well, the file name, let's say it this way. Okay, just for the moment, I'm gonna use a full path, so I've got to find what it is. Okay, so my path is C users Lucas desktop intro to Pi. This was different thing, so let's intro to Pi. Okay, and this was desktop. So this is likely what you've got when you're on the Windows. When you're on a Mac, it would look more or less like this, and then there's gonna be directory where your files are sitting. So there might be something here, and then this is gonna be the file name. So this is for Mac people. Okay. So the first argument is the name of the file, including the path for a moment. Second argument is so-called mode. We want to open the file. With files, we can either read them or we can write them. Or another option, we can append to a file, which means start adding things to the end of the file. In our case, we want just to read the file, so the mode is specified by providing R as a second argument. Okay, so we do have our sig variable waiting for data. We've got the file that's open. Okay, and once the file is open, we're assigning the result to my file. It's called, in jargon, it's called file handle. It's something that we're gonna be using when handling access to the file, okay? And once we've got this thing defined or assigned, then we can start using it. We can just loop over the file handle, okay? And initially we can be just curious what's there. So let's print ln. Okay, so here's our script, and let's try to see if it runs and hold our fingers crossed. Yes, it works. So now what happened here? Well, we created the seg variable, which we don't use, so it doesn't matter. We opened the file. We got a file handle from the open as a return from the open function. The file was opened in a read mode, so we can now read from it. And if file is open this way, then we can loop over file handle. And every time we loop, passing through the loop, we're getting a variable set to the next line that was read. So here's the first line in a source, this guy here, and then we're getting the second one, third one, fourth one, and so forth. You notice that the printout has spaces in between. This is because the line is returned with the new line character there. My file, no, it's more complicated. It's not exactly a list. It's iterator. It's internally. It's something. It's so-called. It looks like a list, but it's not list. Let's say it this way. And the reason is files can be horrendously large and might be larger than the memory of the computer you're trying to read the file. So if my file was the list of all the lines, then you won't be able to read files larger than the memory you've got access to. So this is more clever internally. It's something more complicated, but it behaves like a list. So you can iterate over my file, and every pass is gonna get you next line from the file, and that's what we're getting here. Each line is terminated by a new line. So when we're printing ln, it contains a new line, and then print is adding new line on its own. So that's why there's extra space here. What we're after is we're after only the sequence characters. So we don't want those new lines. We don't want the first line. So we've got to take care of that well. So first we've got to drop the first line. So we're gonna drop a line starting with greater than. That's one way to do it, right? So we're gonna check if a line does not start with greater than, and only then process stuff, okay? So now let's stop printing this, and now we're gonna just print this line, and we're gonna make print not add the new line character, and let's see what happens. What happens now? Okay, so now R is used. The R means that we want to read. R stands for read. We want to read this file. Another option is to use W for write, but we don't. But this is when you want to put your data into a file. So you can either read or write. We'll get to write just in a moment. So for exit, but not for opening. For opening, I don't think X is, I mean, you can use either RW or combination or RW or something like that. This is just for reading. Open doesn't run files. Open just reads and writes. Okay, so here's our modified script, but that is gonna skip the start line, and prints are not gonna print new line at the very end. Let's run it. And here is the everything in the file other than the initial header. Okay. So now we want to collect all those characters in a sequence in our seg variable. Okay, and we want to guard ourselves. Well, we want to get rid of the new line. You see, this is adding, each line terminates with the new line. That's why we're printing up one line at a time, because print here doesn't generate new lines. So those new lines must be coming from the file. So let's get rid of those. And after getting rid of new lines, let's put them to a sequence. Let's append them, append incoming line to the sequence. Okay, so here, and we're not gonna print it anymore. And once the file is read, we're gonna fall out of the loop, and then let's print what we've got so far. Okay, so now when we run it, we're print seg strip. We're still well, we'll still seeing something that's wrapped, but this is artifact of the running in the console. When you make changes there, this is actually one long line. We've got the first line going up to here. There used to be a new line here, so it's missing. So the next line starts here. So this is console wrapping. We effectively got rid of new lines by stripping. Okay, we still get rid of the spaces somewhere every now and then. So then we can do whatever we did before, which is we can replace every empty space with nothing, and now we can run it once more, and now we've got the sequence as a one very long string with no spaces there. So we've read our sequence. Because we've got to both replace, well, because replace space is not going to replace a new line. Replace, we would have to run replace, and then we would have to run also replace backslash n. We would have to run this. I guess we would have to run replace twice. So I prefer to strip to get rid of stuff in front and at the very end, whatever it is, and then get rid of spaces by replacing. So that's why I'm doing it this way. Okay, so here we've got our modified sequence, and just in case someone had the sequence with capitals, then I can go to lowercase, and this way I do have in a entire sequence with no empty spaces, nothing else but the sequence characters all in lowercase. So here I've read the file. Strip is removing so-called white space. So those are things that you don't see as characters. It includes the regular space, something what you generate by pressing spacebar, but it also includes tabs. It includes new lines. So between nothing. Lower doesn't take any arguments, but it's a function, it's a method, so you've got to provide empty list of arguments. So if it was called like this, Python would look for a variable named lower sitting in a or property of a sequence called lower. But this is not what we're looking for. We're trying to run a method called lower. So that's why empty list of arguments. For strip, yes and no. For strip, you run it without any arguments if you use the default things there, but strip happen, but strip might take something else. I don't exactly. So default arguments might be hidden in a call. So it would require looking in documentation to find if there's any arguments that one can add. The empty argument list means that there's either no arguments or we're using arguments that are default in general. But if we want to call a method, there's got to be pair of brackets. Okay, so we've read the file. The last thing to do is we've got to remember to close the file handle. The reason is that when program is opening the file, it might do something with this file, with access the drive, and then when we don't close the file, it might mess it up. So the good practice is to keep files open only as short for as long as we need it, and then close them immediately. So it's actually better to have this my file close sitting just once we're done with reading the file. This is safer. For reading files, it doesn't matter that much. For writing files, it matters. If you run a program and write something to a file, and either there's a power down or your program crashes, it might happen that the file is gonna get messed up. So you make sure that the writing is done. The files are opened for as short time as possible. So here's the version of the script that just reads our sequence file and puts the sequence into seg variable. Okay, because of this problem with opening and closing files, there's another version of reading files which makes it easier on you. It makes it closes the file automatically. So here we're opening somewhere here, and then we've got to remember to close it once we're done. It's sometimes hard to remember to close the file, especially if when reading a file there's a lot of stuff happening, and this close ends up in a basement in 200 lines below. So to prevent you from forgetting about close, there's another variant of reading or opening files. what we do is let's change the path here. Desktop intro intro to Pi. That's intro to Pi here. So here's nearly exactly the same script. We're having the sequence waiting for the sequence variable waiting for the sequence to come in, but now we're gonna say with and then open function as my file. This is equivalent to whatever we've got here. The advantage is that now once the block of code following with is done, so once we were done reading the file, this my file close is gonna be called automatically. So we don't have to close files anymore. We can just say with open as my file, and now in a block that's now got to be indented, we're doing exactly the same thing as before. We've got the same loop here reading the files, except that it's indented inside the with block, and it means that the file is gonna be closed once we're done reading. So now we can do the same things here, and hopefully we're getting same stuff here, except that I didn't. Now I went to upper, so I can go to lower. So here's exactly the same thing. This is in general preferred, because this way you don't have to remember about file closing, but it's worth to know that files do have to be closed. Okay, so here's reading a file. Writing a file is similar, except that we do need something to write to a file. So let's have a sequence here to write. Now once more, I'm gonna use the with format. I'm gonna modify the path, my new file W. Now I'm opening the file in a write mode. So here the file is gonna be written to, okay. And I'm gonna use my file as a file handle. Why not? Okay. So once I've inside the with block, now I've got a file handle I can write information to. To do it, I use a method called write, which takes only one argument. This is what is gonna be written to a file. It's sort of similar to print, but not exactly. Write doesn't put a new line at the end of a line. So if we want to put multiple lines in a file, we've got to remember about appending a new line at the end. And I think write takes only one argument. So you can't put multiple arguments there, hoping that they're going to be glued together. You've got to do the gluing on your own. So that's why I'm taking a sequence here, and then I'm appending new line. Okay, and I don't have to remember about closing, because the with is gonna close things. Okay, so now let's try to run it. The file is gonna end up in a directory I specified here. So let's try to run this thing. There's gonna be no file C intro to Pi my, where is it? With open user intro, what did I use? See users look in, oh, desktop. So here's my path. Okay, let's run it. Now the program is happy. If I go here, then now I've got my new file here that was just created. I can get rid of the file, and then when I rerun it, the file, come on, the file reappeared, and it does have the sequence here. The warning here is W, the writing file. Actually, writing to a file means actually erase the file if it's there, and then start writing there. So when I run this thing multiple times here, let's say 2-3 times, and look what's in my file, there's only one line there because before writing to a file, I erased the file, made it empty. To append to a file, you've got to change to A, okay, as a mode. And now when I run it 1, 2, 3 times, let's say, now I'm getting lines appended to a file. So this is the difference between, yeah, recording is gonna go on into the box. Okay, so that's how to add. This is how to append to a file. That's the difference between W and A modes. So that's simple. Simple way of reading and writing to a files. We're nearly there. We've got to read one more file in a little bit more complicated way. So let's try it. I've got another file also ready there. Here's the codon table. This is a file with a standard codon table. So you've got the codon. This is the triplets of DNA or RNA bases. This is, I'm using the DNA letters, not uridine, but thymidine. So this is codon. This is single letter amino acid code. This is 3-letter code. So K is lysine, N is asparagine. Asparagine. This is K is lysine, and so forth. So this is my codon table. Okay, wherever there are stop codons, I've got either dashes or full name of the codon there. So now how to read it? That's right. Well, I'd like to make myself a dictionary, or actually 2 dictionaries. One is gonna have as a key the codon and as a value single letter code, and the other one will have as a key also codon, but then the 3-letter code. So I've got to read this file, this line, read this file one line at a time, split each line into 3 parts, and then put them together into those 2 dictionaries. How to do it? Well, first we've got to open the file. But before that, I'm gonna actually make myself 2 empty dictionaries that I'm gonna start filling in. Okay. Then I'm gonna open the file for reading. I've got to be careful to make sure that I read this file. If I put W here and run this script, I'm gonna erase my codon table. So it's good to be very careful when opening files in the right mode, because you might destroy your data. So be careful with that. So here's got to be R, okay. And now once the file is open, and provided I've got the right directory here, which is supposed to be desktop. Okay, so here I'm opening my file for reading. My file handle is my file. So now I can go one line at a time. I'm stripping so that the new lines are gone. I do not remove white spaces because I want to use them to split lines into 3 parts. So removing the white lines would be painful, let's say. So I'm gonna only strip, but instead of replacing white spaces, I'm gonna split line with no argument. This splits on an empty space. This is equivalent to splitting on empty space. Okay, so now what? Well, let's look at the file. We've got lines that are either empty. Here, the list returned by the split is gonna be of size 0. There's nothing there. We're interested only in lines that will result in a list of length 3, and then the first element is gonna be codon, and then 2 different versions of the amino acid code. So let's see how to deal with this thing in the script. Okay, we've already split into columns, so we've got either 3 columns or 1. We care only about calls if there are 3 of them. So here I'm testing if there are 3 columns, and if there are 3, well, then I'm gonna put into a single, this is my dictionary for a single letter code, I'm gonna put as a key whatever is in column 1. This is my codon, and then I'm gonna put the second column, so this column with index 1, this is a single letter code. And the same thing for the AA long, except that I'm using as key the codon, and then I'm using as a value the 3-letter code. Okay, and once I'm done with this thing, I print my AA long to see what happens. Let's see. Let's run it, and here's my codon table as a dictionary. And this is the long version, so I'm getting 3-letter codes for amino acid. This is my codon, this is my corresponding amino acid, codon, corresponding amino acid. So once I've got this thing, it's sort of useful, because then if I look for, if I'm curious what's the amino acid corresponding to triple A codon, if I run this thing, is not I can get, now I know that AAA codes for lysine. So here's another example of reading a file. Okay, so that's about it. You've got all the bits and pieces to actually write a program that can try to take the sequence you've got here and translate this sequence into possible amino acid sequence. Well, to do it, you've got to read the file, as you've seen just a moment before. You've got to read the codon table, as you've just seen before, just a moment before, and then you've got to start translating. Okay, so then you've got to come up with a way of splitting your sequence into triplets. So you've got to go and split this thing into GAG, AC, and so forth. Okay, and then for each of those, you'd be able to find the amino acid code and then print this thing out. The tricky part is first how to split. There's more than one way to do it. One way might be you generate a sequence of indices that are corresponding to first position of each triplet. So you've got to generate 0, 3, 7, 10, and so forth. So range is your friend, okay? And then once you know what's the first position, then you can slice and get the three things using three consecutive characters using slicing operator. So this is one way. So here's the one tricky part. And then the second tricky part is we don't know in what reading frame the translation happens. It might start like this, okay, but it could be that it starts here in so it could be, let's get myself this, okay, copy, let's get myself this thing here. So here's an annotated piece of sequence. So it might be translated like this. TTG. Okay, this is one. But it's also possible that reading frame is off by one, and we've got translation like that. Those two alternate reading frames will result in a different sequence of a possible sequence of amino acids. So for a given sequence, there are three possible translations. Now, it is also possible the translation go backwards from the other strand of DNA, if this is a DNA sequence. So then it's not the sequence that we've got here that's translated, but it's the reverse component that's translated. So then you've got to generate a reverse component and then translate it once more in three different reading frames. So those are three tricky parts about the whole problem. If you feel like writing this thing, write the code and send me the file, and I look through this thing and comment. If you've got questions about how if you get stuck, we can set up a Zoom meeting and go over this thing. And if you want to test if the result is if you're getting what you should get it, the script is essentially reproducing whatever the XPazi.org web page is doing. If we go there, there's a web page. Okay, translate. It takes a sequence, so we can get a snippet of sequence somewhere here. Okay, whatever it is. Okay, and then if you paste it in and check, let's say compact M dash no spaces, and use both forward and reverse, when we run it, okay, then you're gonna see what your script is supposed to return. There are three reading frames corresponding to three different positions of the codons along the sequence that was provided originally. Okay, so those are those three. And then there are three reading frames for the reverse complement. So your program in principle should return something like this without the colors and whatever, just 6 different sequences corresponding to whatever are the possible translations. If you wonder, you can tell which one is real by looking for regions where there's a long stretch of amino acid residues starting with M and with no stop codons in between. So the most likely reading frame for this piece of sequence is here, because you've got a long stretch of amino acids starting with methionine here. Maybe there's something in front of it. So here's something to check what the script is supposed to do. Once more. There might be more. It's depending how long is the sequence, and depending if it covers 1 or 2 reading frames, so it varies. But this is essentially the first step of trying to analyze what the sequence coming from whatever organism is actually doing. The first thing to do is to find where the reading frames are. So you've got an annotated piece of DNA, and then you translate it in all the possible reading frames in both orientations, and then you're going after stretches that correspond to longest possible reading frames. So you've got six reading frames, and there might be things coding for protein on both strands, and there might be one or more of those. So this is just to get to the starting point. The problem is, interesting enough, that Swissprot is that Swiss Institute of Bioinformatics XPAS is actually having a website that does it for you. I'm using it all the time when you sequence a plasmid and you check if the sequence is correct. I tend to paste the resulting results from sequencing there and check what's there. So yeah, I'm gonna get you. Okay. So and then that's about it. Okay, I'm gonna download this thing today, because you do need it to deal with opening and whatever with the file. So this thing is gonna show up today. I'm gonna do it just in a moment. Well, not in a moment, because I've got another Zoom meeting in 10 minutes. So I'll do it somewhere around between 8 and 9 p.m. Okay, and that's about it. Thank you very much for your patience. I'm stopping the recording. Let's see. Stop recording. Okay. Yeah.